Hello and welcome back to this lecture series on signals and system. So now let's look at deterministic and random signals. Uh, so we're going to be looking at the first one, which is the deterministic signals. So by definition, what can we say about that? Deterministic signals can be described mathematically as a function of time. As a function of time. Exactly. So mathematical as a function of time. So now let's look at that's just the definition, but let's look at the drawing. I think it would make more sense if you see what the diagrams of, the diagram of deterministic signal looks like. All right. So for deterministic signal is something like this. Just so it's actually look more. These lines are vertical lines, straight lines like this, and then it can just continue like that. Exactly. So the deterministic signal is just something like this. This is just a freehand sketch. So it's like so the thickness are always the same thing. Exactly. Is it the way you call it? So they're actually the same thing, but because it's freehand sketch, they might look a little different. All right. So then, if you had to give it the vertical and the horizontal axis, exactly. So this can be, let's call this. So if this is 0, minus 0.5 minus 1, and then this will be 0.5, and then this can be 1.0. Exactly. So the intervals will be definitely be the same thing. So if you can give it to this point here, if you should call this place 0.5, and then so the next one should be here. Also, let's just shift it. So let's just call this 1.0, and then the next one is 1.5. So this is how that of, and then this is going to be the time. This axis is for time in seconds, and this is for the amplitude. That's the amplitude of the signal. So you can see this is just a rough sketch of what it's the diagram of deterministic signal looks like. You can see the thickness here, they are the same thing, including this, the gap here, they are all the same thing. It's just a very neat kind of signal. So that's the deterministic signal. It can be described mathematically as a function of time. So you can see that the time here is constant. The time difference between each of those signal is actually the same. All right. So now let's look at what about if we talk about the second one, which is the random signal. So for random signal, so you say that random signal. So if you have to define a random signal, to say something about it, a random signal. So it takes, just like the name, random, statistically characterized random values. So we are going to compare its values at any given time. At any given time. So now for this random signal, a typical example is noise. So you can say that a typical example of random signal is noise. You might have come across some of how noise looks like in form of wave. So let me just do a rough sketch of what that actually looks like quickly. Okay. So if you're looking at for noise now, you're going to be looking at having something that looks like this, I hope you get what I'm trying to do. Just like frequency, you can see. So if you have to look at it with the definition that we have here, okay. So it can be low, it goes high, it can just stay, something like that. So that's how it looks like. Then it will also have its own amplitude. So don't forget to have its own amplitude depending on its range. And then so this is also going to be the amplitude, and then this is going to be the time. So depending on the values you are using here, so maybe 50, 100, 150, then continue like that. But this is so you can see that it is not if you compare it with deterministic, you can see the deterministic is well arranged. The intervals are just equal on the horizontal axis, but unlike what we have here, you can see it is not well defined. So, and that's how noise signals always look like, something like this. Exactly. So that's it on random signals. A random signal takes random statistical characterize random values at any given time. You can see it can just take any value at any random time. But unlike here, you can always see that it has a very constant waveform. Let me put it like that. So that is it on deterministic and random signal. So far we've looked at how many of all the 7. Let me just confirm real quick. And then in all the classification of signal, we've looked at 7 of them, the 7 classification of signal. So I hope you find value in all of this, because the next one we are going to be looking at is in this lecture series, we are going to be looking at the continuous time signal. So that's like the unit step function, the ramp function, and the likes. So if you want to see more of that, you can just make sure you click on that subscribe button so that you get notified as soon as those videos have been uploaded. And then you can also check the playlist on signals and system. You'll find all of those videos there. So if you have any questions with any of the video, just or any comments, just leave them on that video in the comment section, and then I'll attend to it. So thank you very much, and then I'll see you all in the next one.